Hello and welcome to Friday's edition of Cracking the Cryptic. And on screen today we've got a puzzle by Nell Gwyn. And Nell Gwyn, obviously the mistress of Charles II. I presume this isn't the same Nell Gwyn. That Nell Gwyn was mentioned in the diaries of Samuel Pepys with much admiration because of Nell's apparent wit and skill and cleverness. So I'm hoping that this Nell Gwyn will also be met with much acclaim from the viewers of Cracking the Cryptic. I'll talk you through the rules in a moment. I will say that Mark has tried this puzzle and he says it's a lot of fun. Now we know with Mark's adjectives he never quite uses them correctly, but let's hope that he's somewhere close to the mark with that one there. Now before we get started, I want to give a shout out for Prasanna Seshadri's new competition on Logic Masters India this weekend. If you enjoy the occasional puzzle competition, you should definitely check that out. Prasanna's designed all the puzzles himself. There are lots of standard variations, and then each variation has like a twisted variation as well. It's called Parallel Universe 4, I think, that puzzle competition. So check it out. I will put a link, of course, under the video. And in fact, that puzzle competition features many of the types of, well, some of the types of puzzles featured in Nell Gwyn's puzzle in this Sudoku, because this Sudoku is a hybrid of spiral galaxies, star battles, and Sudoku. Let me read the rules. We've got normal Sudoku rules apply. The dots are the centres of rotationally symmetric galaxies, whose digits sum to the number beside the dot. Digits may not repeat within a galaxy, and galaxies may not overlap. Each row, column, and 3x3 box contains exactly 2 digits, no more, no less, that are not part of any galaxy. Those digits that are not part of a galaxy are lone stars and may not touch other lone star digits orthogonally or diagonally. So that last bit of the rules is classic star battle. Now the reason this puzzle actually came to my attention is that last month on our Discord server we had the theme that people had to sort of adhere to and create puzzles around was stars and galaxies and planets, and Nell Gwyn created this one, which is called Spacewar Sudoku as a result of that. And that's why we've got galaxies and star battles going on. Now, if you're not familiar with spiral galaxies, let me try and explain what's going on. What we've got to do is, let's look at this 10. You see there's a dot in the middle of the 10. Now, we've got to decide whether this is a 2-cell 10 galaxy, or if, for example, we thought this square here might be part of this 10 galaxy, then we must include the rotationally symmetrical cell as well. So that's that cell. So this would then be a 4-cell 10 region. It couldn't be any greater because although we could build a bigger galaxy, you couldn't make the digits in that galaxy add up to only 10 because they'd all have to be different. And if there are 6 different numbers, that would add up to a minimum of 21. So that's what we're going to have to do. We're going to have to divide the grid into galaxies while leaving enough room for these stars. So yeah, it sounds brilliant. I absolutely love Spiral Galaxies puzzles, and the Spiral Galaxies puzzles I've done which have been hybrided with Sudoku have been brilliant. So do try it. The way to play, of course, is to click the link under the video as usual. With that, I get to play. Let's get cracking. Okay, so my eyes immediately are drawn to box 1, I have to say, because this dot is quite powerful because it covers 4 cells. And this dot covers another 2 cells. And there's a few things I'm thinking here. The first is that it's not possible for this 24 galaxy to just be this size, because if it was, those 6 cells would add up to 40. And we know that every box, every row, and every column of a Sudoku adds up to 45 because it contains the digits 1 to 9. So if this was the shape of these galaxies, then these 3 squares would have to sum up to 5, which is impossible. So this 24 is going to have to grow. But before we get to that, the other thing that I've noticed is that I've got to put 2 stars into box 1. Where are they going to go? They can't go next to each other. I can't put them both in this domino. So this square has to be a star. And that means there's no stars around it. Now I'm going to have a problem here. Because normally when I do spiral galaxies, I like to colour the galaxies. But when I do star battles, I like to colour the squares that can't be stars. So, I wonder if I can... Let me just... yeah, okay. What I'm going to try and do, because I've just noticed I can actually place the stars in column 2 here. Look, where do the stars go in column 2? I've got to put 2 stars. I can't overlap them with galaxies, so that only those 2 squares can be stars, I think. So I think I'm going to try and place some stars first, and then we'll look further at the galaxies after that. So all of those squares can't now be stars. Those are not stars. It does appear like the Battle of Britain is going on outside my window again with the aeroplanes. Sorry about that. Nothing I can do about it. Now, where do the 2 stars go in box 4 now? One must go there. So there's a domino there that contains... I'll put blue for a domino that contains 1 star. That's part of a galaxy. So that's a domino. So we've approximately located the stars in column 1. Those can be greened out because they... In fact, what I should do, you know, is I should just colour in all of the cells that are on galaxies. That would be sensible. Let's do that. All of those can immediately be greened. Yeah, okay, this was a sensible idea because now we can pick off more stars. There have to be 2 stars in column 4. 1 has to be here, 1 has to be in this domino. Now we can't put a star here, look, because if we do, neither of those squares could be a star, and that will break column 4. So this is not a star, which means this is a star. That's not a star. This is a star. This is a domino. This... Oh, we can't touch the star here, so those 2 become green. We can label that one. We've now got, look, 2 stars in the bottom row. So that turns green, that turns grey, that turns green. Where do we put the 2 stars in box 3? One's there. One domino. Ah, yeah, that's interesting. Look, in row 1 now, as this domino has to contain a star, and this is a second star, we can't put a 3rd star, so that becomes green, sorry, that becomes a star. 2 stars in box 6 they cannot be together, so we get all of those green. Yeah, this is gorgeous. We are almost done with our stars. Oh, what did I do there? I tried to put a star here and it didn't appear. There we go. And 2 there. We've got 2 now in row 4, so that one, and there we go. Now let me just take a quick stare at this, just scanning to see whether I've got 2 in every row, column and box. I think I do. So that is the arrangement. Now, oh, if I was in the new software today, I could just immediately double click on a green cell and remove the highlighting from every green cell in the grid, but I'm not, so I'm going to have to do it the slow way, which is like this. So all of those squares now become white, and we have a different problem. So we've done star battle, now we have to do spiral galaxy, and then presumably we'll do Sudoku. So every white cell now in this puzzle has to be part of a galaxy. Okay, well there are loads of, we can do quite a lot here actually. Look, this 24, we know this square in the top left hand corner of the grid has to be part of a galaxy. Well, it can't reach any other galaxy other than this 24, and the rotation of this cell around this dot is that cell, so this is a galaxy. It obviously can't take this square as well because that reflection would be off the grid, and that doesn't work. So that 7, look, can't go anywhere. It can't go up here because if it does take this cell, it needs to take that cell, and that's definitely part of a different galaxy. So that 7 is in fact just a 7. I will colour it in so it doesn't feel left out, but this cell now has to be part of the 24, so all of those cells get filled in. Those are all part of a galaxy with the 27. That 8 is now fenced in, look, so we get that galaxy. The 16... No, the 16 can't take this square because, again, the reflection of this square around this dot is that square, which is part of the 24 galaxy. So this is now that's a 16 galaxy and is 7 and 9. We could actually do a little bit of Sudoku. I don't know if we need to, but look, that's 7. this 24 galaxy is 7, 8, 9. That's the only way of getting to 24 in 3 squares, and the 7 can only go there, look. So those 2 squares must be 8 and 9. It's a little bit hard to see the pencil mark there, but it is an 8 or a 9, trust me. Right, this square must join up to this 24, so that 24 is forced. It must look like that. This square must belong to the 12, so the 12 looks like this. Ah, that square's a little bit interesting. Which galaxy does this join? Well, if it comes over here, it would have to join the 15, and that would reflect to some cell over here off the end of the grid, so it doesn't come to the 15. If it comes to the 10 would be far too large, and it would have to have a reflection off the grid. So it's going to come to the 21, and therefore all of those cells must be, in fact exactly those cells must be the shape of the 21. You can see if we try and pick up this one, the rotation is onto a star. If we try and pick up this one, again the rotation is onto a star. If we try and pick up that one, the rotation is onto a galaxy. So the 24 gets fixed. The 8 must live on its own, look. And I will give it a colour. I will make it red. The 6 could live on its own as... no, the 6 doesn't live on its own because of this cell. This cell is either a member of the 6's galaxy or a member of the 41's galaxy. But if it joins the 41, again the reflection is off the grid, so it joins the 6 and creates a 3-cell region, which must be 1, 2 and 3. Which means this cell is part of the 41. In fact, look, this 41 basically acts as a gate now for all 3 of those squares, so it must be exactly that shape. And we can do a little bit of arithmetic. In fact, we can do arithmetic and get this digit now by looking at box 7. Because if the red cells add up to 41, the grey cells must add up to 45 minus 41, which is 4. And the only way of making 4 in 2 cells, if you can't repeat a digit, is 1 and 3, which makes this square 2. This 9 is hemmed in. It can only be a 9. And I'll make it blue. The 16 must pick up this square, so yeah, it must be exactly this shape. It can't take any other digit. This cell is interesting. This must join the 10. So the 10 does look like that, which I think is the example I looked at right at the start. And 10 must be 1, 2, 3 and 4. And this square, look, sees a 1, 2 and a 3 in the row. So this square is a 4, which means there's no 4 in there. The 17 can't go anywhere, so that is 8 and 9, and it's in its own galaxy. The 13 can't go anywhere without reflecting off the end of the grid. The 14 must go up here. The 17 can't go anywhere, so that's a 2-cell galaxy. And the 15, to complete the galaxies, looks like that. And that is the shape of the spiral galaxy. So we've now done Star Battle and Spiral Galaxy, and we just have to do Sudoku now. So let me just stare at this for a second and see if I can see. So that's got to be, oh look, this is an 8-9 pair, and there's an 8 over there, so that's 8, that's 9. Anything else here? Yeah, look at box 3. We can do arithmetic on it. So we've got 27 in those cells, plus 8 is 35, plus 7 is 42, which means the grey cells have to add up to 45 minus 42, which is 3. So these cells are 1 and 2, which fixes our 8 cage. The 8 cage must be 3, 5, because it can't be 1, 7 or 2, 6. Now 9 is this 9 pair here and this 9 pair here force this square to be a 9, which forces this square to be an 8 by Sudoku, given there's an 8 here, which means this is a 4, 6 pair. And we are almost cooking with gas, I think. We've got 13 in this column without using 4, 9 or 5, 8, so that's 6 and 7. And what now? Oh, I tell you, there's something easy. We've got a 1, 2, 3 triple in row 7, and in this square, looking at the column, the only options for this square are 1, 2 and 4. So it can't be 1 and 2, so it must be 4. Which means this square must be 1 and 2. One, 2, 3, 4. So this square here, 9, 8 here, of course. Let's just fill that in while we're here. So 1, 2, 3, 4. This square here has got to be 5. This square here can't be 6 or 7. That square is a 5. It's a naked single. So now looking at this row, we've got to put 6 and 7 in to complete it. 5. 1, 2 and 3 into these 3 squares. Now, can we get maybe the 14 cage? Look, we've got a 5 in it, so these 2 cells have got to add up to 9, which means this square here has got to be 6, 7 or 8, but it can't be 8 because there's an 8 there, so that can't be 1, which means there's a 1 at the bottom of the grid in here. This 1 means this square can't be a 1, so we get a 3 and a 1. That square's a 1 now. And oh, there's a little trick we can do on the 16. This 16 is 4 cells large, but look, we've got 1, 2 and 3 already used up in this box. So what can these squares be as a minimum? Well, the minimum they could be would be 4, 5 and 6. And 4, 5 and 6 add up to 15. Now, given I don't want to put 0 or a minus number in this square has to be a positive number, so it has to be 1, and this does have to be 4, 5 and 6. 2, 3 pair here now. So that square at the top is a 1, 2, 1. 2, 3. So now these 2 squares are 7 and 8 in some order. So by Sudoku, look, we've got 8s here and here, 9s here and here. So these 2 squares are 8 and 9. And those squares have got to be 2, 4 and 5 to complete this box. The 2 sees that square. So that's a 3, that's a 2, that's a 6 to make the 14 work. And we are doing nicely today. 4, 7 into this domino. So we get to complete the 15 galaxy look. We've got 12 so far, we need 3 more. And those 2 squares have got to be, these 2 squares have got to be 2 and 5. There's a 2 here, so 2, 5. Now these 2 squares have got to be 9 and 7. We get those as well. The 7 fixes the 7 and the 8. This 9 fixes the 9 and the 8. Brief hiatus, I hope, while I try and spot something else. It's got to be a 1, look, in this 24 cage. It's got to be in one of those 2. And there's a 2 in it. Look, there are 2s as well. So we're up to 10. Oh, yeah, this is good. Yeah, this is good. Look, we've got 10 in 3 cells of it. So the other 2 cells have got to add up to 14 without using 9. So we need 6 and 8. And the 8 here means this must be 8. So that's 8. We should have a 6 along this line somewhere. So 1, 2, 6. And those 2 squares have got to be 3 and 5. But I probably can disambiguate them, but I can't see how. Which is one of the frustrating things about Sudoku. Maybe we can we do arithmetic on this box maybe? Oh, not this box, this row. Because I've got a 12 cage there. 12 plus 10 is 22. Plus 16 is 38. Okay, so these two cells in this row must add up to 7. And this is a 4 or a 6, so this is a 1 or a 3. Now that's, look, we've got a 1-3 pair now in column 3, but that doesn't really help down there. Does it help at the top? 1 is oh, no, hang on. Oh, yeah, now this is good. This is good. Here's some good logic. Does that 24 cage have to contain a 1? Well, the answer is most certainly it does, because 2, 3, 4, 5, 6 and 7 add to 27. Now, therefore, where am I putting the 1 in the 24 galaxy? This one means it's not in there, this one means it's not here, and this 1-3 pair means it's not here, so it must live there, which gives me a 1 here by Sudoku. And a 1 here. Ah, these ones sort of bounce back again into box 1, therefore. That's nice. So that's a 1, that's a 3, that's a 1. Oh, of course. And now those had to add up to 7, didn't they? So this must be a 6, that's a 4. This must be a 3, 4, 5 triple. And we've not placed 2 and 6 in box 2, so this 2 and 6 into these two squares. 2 and 6, which sounds like the price of something back in Nell Gwyn's time. I'm not quite sure what Nell Gwyn would have sold for 2 and 6. Perhaps it's best not to dwell on it. That's not 6, because we've got a 2-6 pair in this column now. Oh, look, I can do arithmetic on this box now. Because of this 1, those 5 cells add to 23, plus 1 is 24, plus 16 is 40, so this square must be 5 in order to get to 45. The 5 fixes the 5 and the 3. I totally agree with Mark for once. This is a fun puzzle. I've got to put 5 in this box. There's a 3-5 pair there, so it must go here, which places a 5 here. So now maybe the 24 cage is useful. I'm not sure, but you can see that because we know the approximate value of this square, that's going to influence the value of this square. And the way we can work that out is if this is 3, those 3 will add to 21. 21 plus 6 is 27. Plus 13. Plus 13 is 40. And that would put a 5 here, which is impossible because there's already a 5 in the box and there's a 5 in the column. This is not 3, this is 5. I hope that's going to work, or I've made a boo-boo. So 19 plus 13 is 32, plus 6 is 38, put 7 here. That looks better. Yeah, that gives us a 7-6 here. That gives us a 7-9 here. That gives us a 9-8 at the bottom. 8 must live here by Sudoku. So now look, we've got 2 and 6 to place in row 2, but this square can't be a 2, so that's a 6, that's a 2, that's a 6, that's a 2, that's a 6. It's hard to see, but it is a 6. That means that's a 6 at the bottom. We've got a 4-5 pair here, which we can do because there's a 5 I've seen here. 2 and 3 here get resolved. So that should be a 3. That should be a 4. That should be a 5. This 7 fixes, I think we're done. 7-4 here. This 7 fixes the 7 and the 6 here. That's probably been there since the very start. Sorry if you've been annoyed about that. Now these squares are 4, 6 and 9. Let's just check. 4, 6 and 9 and 5 do add up to 24, which is good. And that's got to be a 4, therefore that's got to be a 6, that's got to be a 9. That 4 fixed the 4 and the 2 at the bottom. That plonks the 2 at the top. And we need 3 and 4 to finish. Oh, not like that. 4, 3. I filled a digit into every square. I've done my stars, I've done my spiral galaxy. Let's click check. What's that say? Yes, looks good to me. We are done. I loved it. Very, very fun puzzle. Hope you guys enjoyed it too. Not too difficult today, I don't think, but nevertheless, extremely enjoyable. Yeah, and lots of different puzzle types to juggle in your head, which is never a bad thing. So, yeah, thanks to Nell Gwyn. I hope you enjoyed watching the solve, and we'll be back later, of course, with another edition. Cracking the Cryptic.